Hi, sir. So, before we proceed deeper to my topic, let me first introduce myself. I am Loquinte, and this presentation is for the subject IS107 Business Intelligence. So, my title is all about the standard deviation and variance of earthquake depth. So, here you can see my title, the standard deviation and variance of earthquake depths. So, in the first page, which is my dashboard. Here, you can see the overview. So this dashboard provides an interactive platform to explore the distribution, variance, and standardization of earthquake depths. Understanding the variability helps researchers and decision makers better interpret tectonic activity and earthquake hazard. You can see also the key features, which you can see the interactive graphs, variability insights, dataset, exploration, summary statistic, and the navigation. And you can also see how to use. Then you can also explore modules where you can select here if you want to understand more about the plotting demo, data table mapping demo, or my title, which is the standard deviation and variance of earthquake depths. So the second page is all about the data frame demo. So here, this visualizes earthquake trends, including average depth and magnitude over time, average depth by province, and a 3D magnitude trend by province and date. So here, you can choose provinces. For example, you can select the province of Abra, Agusan del Norte. Then, you can see here the average earthquake depth kilometer over time. So, and the table displays the average earthquake depth for each selected province, and the chart visualizes depth trends over time. So the interpretation is shows how deep earthquakes typically occur in different provinces. So deep variation can indicate whether earthquakes are tectonic, deeper or near surface, or shallower. So at steady depth, trend may imply consistent seismic activity, while the sharp changes could suggest significant geology shifts. Then the next visualization is the average earthquake magnitude over time. So the table shows display the average magnitude per province. So the chart shows temporal trends in earthquake strength. So the interpretation for this chart is to help identify periods of stronger or weaker seismic activity. An increasing trend in average magnitude might signal escalating tectonic stress, while sudden spikes could indicate significant seismic events. Comparing provinces reveals which areas frequently experience stronger quakes. So, the 3D earthquake magnitude trend by province and date. A 3D scatter plot here, as you can see, showing the distribution of earthquake magnitudes over time across provinces. So this plot offers a multi-dimensional view. You can view here from here. So the x-axis is the time progression, while the y-axis is the province. Then the z-axis is the earthquake magnitude. So clusters or patterns along the z-axis show magnitude trends. For instance, if a province shows repeated high points, it may be seismically more active. So the 3D view helps compare activity across both time and region simultaneously. Next page, which is the mapping demo. In here, you can visualize the geographic and temporal distribution of earthquakes using official fieldbox data. Use the filters to explore magnitude, depth, and location trends over time. So here, in the earthquake data controls, we can filter earthquake data. We can filter the province. You can select all, or you can select each provinces. So let's select all. Same here in year. You can also select the magnitude range, which is from 0 to 10. And then the depth range kilometer from 0 to 700. You can also select the date range, for example, 1. So here we have the map layers. If you want to view the earthquake magnitude circles, you select this. So in the earthquake magnitude, which is circles, in the map, so this layer shows uses red circle size based on magnitude to represent where and how strong earthquake occurs. So the interpretation is the larger circles indicate stronger earthquakes. Cluster of large circles here may suggest seismically active zones. Comparing circle sizes over regions helps identifying where more powerful earthquakes tend to strike. Then you can also select the depth visualization, which is the 3D bars. So in the depth visualization, 3D bars shows that the 3D hexagonal bars based on earthquake depth using the hexagon layer. So higher bars represent deeper earthquakes. So tall 3D bars, hexagonal bars based on the image. So indicate deeper seismic activity, possibly tectonic subduction zones. So the short ones suggest shallow quakes often felt more intensely on the surface. So the 3D bars helps distinguish that distribution geographically. Then you can also select the map layers, which is depth color points. Depth color legend, blue is equals to shallow, while the red one is equals to depth, deep. So as you can see, so points colored from blue is the shallow, while the red one is the deep, based on deep kilometer. So blue points is equals to near surface quakes, where the red one is the deeper ones. So offers immediate visual contrast for deep patterns. So useful for identifying the variation even in clustered areas. And then let's proceed to the other pages, which is the plotting them. Here you can visualize the standard deviation of earthquake depth kilometer by area. So this bar shows that the statistical deviation, either standard deviation or variance in earthquake depth per area and province. So higher value means earthquake depths in that location vary significantly, both shallow and deep event occurs. So lower value means earthquake depths are more consistent in that region. You can filter this and select the magnitude. So here you can see the average earthquake magnitude per area and province. So the interpretation for this is that these bar charts shows the average magnitude of earthquake recorded in each area and province. So areas with higher average magnitude may experience stronger quakes more frequently. magnitude versus depth, which I use the scatter plot. So this animated scatter plot shows the relationship between earthquake magnitude and depth over time. So shallower earthquakes, lower deep values often appear across a wider range of magnitudes, while deeper earthquakes are less frequent and may be isolated with specific tectonic zones. The animation helps observe trends in seismic activity over different peaks, giving insight into how deep and magnitude interact regionally. So you can spot clusters that might suggest active fault zones or repeated seismicity in a given depth range. So let's continue with the last pages, which is the earthquake depth variability analysis. So these analyze earthquake depth variability using standard deviation and variance. So study or review this project analyze earthquake depth data in the Philippines with standard deviation and variance of depth, assessing how depths vary over time and by region. The methodology summary, which is you can calculate and visualize mean, standard deviation, and variance of earthquake depth. Filter data by province, month, and a year. So we used histograms, box plots, and line graphs, and etc. to understand depth variability. So summary statistics. So mean depth is equals to 29.91 kilometer. Standard deviation is 37.70 kilometer, while the variance is 1,421.49 kilometer. So you can filter earthquake data from my CSV file. So this visualization for here is first is the depth variability by province. So use the bar chart. You can choose statistic to display either the standard deviation or the variance. First, we need to visualize the standard deviation. So, this bar chart shows how much earthquake depths vary within each province. So, higher standard deviation or variance means earthquake depths fluctuate greatly in that area, suggesting more complex or active tectonic settings. So, provinces with low variability may have more consistent seismic behavior in terms of depth. So, same here in variance. So, second is the visualization histogram of earthquake depth. So the histogram displays the frequency of earthquake events as different deep ranges. So a single peak suggests most earthquakes occur at specific depth, while a spread out distribution implies more variability. For example, a peak near the surface indicates many shallow earthquakes, while a wider spread indicates diverse earthquake depth. So the third one is the back of earthquake depth by province. So we can select provinces. For example, we can select Abusan del Norte, or more. For example, here. So the box plot show the distribution of depths within each province. So the box represent the middle 50% of values. So the line inside the box is the median depth. Whiskers and outliers indicate streams. Provinces with longer boxes or whiskers have more depth variability, while compact plots suggest consistent depth ranges. The fourth one is the depth variability over time. So this chart tracked how the standard deviation and variance of earthquake depth change monthly over time. So SPY suggests months with large variation in depths. So stable trends imply consistent seismic activity. So this helps identify time periods with unusual depth behavior potentially tied to specific geologic events. So the fifth one is the visualization of depth variability So deviation by year and month using the heat map. So this heat map visualizes how deep variability change across months and years. So brighter or warmer colors indicate high variability. So color tones signal consistency and depth. So it helps detect seasonal or yearly patterns in how earthquake depth vary. So the last visualization is the 3D plot of earthquake depth. So the 3D scatter shows each earthquake in terms of longitude, the x, then the latitude y, and the depth, which is z. So clustering of points at certain depths suggests common fault zones or the active layers. So colorful regions also helps visualize separate depth versus shallow events. So it gives a spatial view of how depth varies, so helping geologists locate active fault regions. So that's also. Thank you.